When creating data visualizations, especially graphs, people often choose colors according to their personal preferences. However, even if you're not a professional graphic designer, it's crucial to understand some fundamental principles of color and how they play a role in communicating information in order that your data visualizations might appropriately tell the story that you're trying to tell with your data. The first thing I want to talk about is some fundamental types of color schemes. That's collections of colors that can work together to portray your data. The first common type is what is called a qualitative color scheme. And this is when you have nominal variables. Nominal variables are categories such as east, west, south, and north that don't have any numeric correspondence but have some meaning, like maybe various cities where your organization might be located. And the only important thing is you want colors that differentiate them, that show different entities without representing any number. So the different numbers are completely arbitrary. They just need to be different from each other. So you need to choose colors that are clearly different that cannot be easily confused. The next kind is a sequential color scheme, and that is when you have colors that represent numbers, but numbers that are specifically positive numbers or zeros. You can have a zero value or positive, but no negative numbers. So you need a color gradient, usually with a light color representing zero or the smallest value, and then moving increasingly darker to the darkest color that you have, but with a unified progression in the color. This is called a sequential color scheme because there is a logical order to the different hues, and darker colors mean larger values, lighter colors mean smaller values. This is a sequential color scheme. The third kind is called a divergent color scheme. And that is where you have positive values, you have a zero value, and you have negative values. And in this case, you'll use two different colors that you might choose, one representing a positive value, one representing a negative value. And it could be either way. Like you could choose blue here as negative and red as positive, or vice versa. But in the middle, you have a light color that is clearly distinct from the two ends, and the you have a sequential gradient from the middle light color to one end, another sequential gradient from the middle light color to the other end. And here, white is a middle color, color close to white, but it might be a neutral color like purple that blends the two. And this is called a divergent color scheme, which again is used for when you have negative and positive values, and in the middle is some sort of zero indication. So whatever colors you choose, you should think about the type of numeric data or categorical data and what color scheme is appropriate. However, thinking more about the specific colors to choose, there are a number of important considerations. Here we want to talk about accessibility. By accessibility, we mean that you're trying to reach an audience and people have different abilities to perceive color, and it's very important to be aware of this in your color choices. The first thing to consider is the importance of using colorblind friendly schemes. We've all heard of colorblind people, but most people don't realize how widespread colorblindness is. In fact, 1 out of 12 men is colorblind, and is much rarer in women. Only 1 in 200 women are colorblind. But when you consider that, that means that 1 in 12 men, we all know someone who's colorblind. Colorblind people don't talk about it very often, but it is extremely widespread. And so here are some links that can inform you more about the prevalence of color blindness in general human populations and the reasons for color blindness. Then here's another a very useful video about color blindness and data visualization, how to consider it. In the previous slide, where we saw various color schemes, whether nominal, uh, whether qualitative, sequential, or divergent, all of those colors are carefully selected to be visible and distinguishable by most, if not all, colorblind people. And they come from Paul Toll, and he talks quite a bit about colorblind friendly palettes and how to think about colorblind friendly colors. Here's a link for creating your own custom color schemes according to colors that you like, but that might fit some of these. To give an idea of what colorblind people actually see, here is a portrayal of normal vision. So here's a colorful page with lots of different graphs. There are three main kinds of color blindness. The most common is red blind. That is people who do not perceive or very poorly perceive red. And this is what they would see. This is how they would perceive what those with normal vision see. And there's green color blindness. This is how they would perceive the same picture. And this is blue color blindness, which is the rarest kind. But you can see here that a lot of these colors they would not perceive. So being aware of these different kinds of color blindness can help us choose colors that are visible or distinguishable by as many colorblind people as possible. Much rarer is monochrome vision, which means people who cannot perceive any color at all. That's extremely rare. But what is not extremely rare are people printing your data visualizations on monochrome printers. That is black and white printers with no color. You might have a lovely color scheme visualization, people print it, and they cannot distinguish what you're trying to tell. So considering how your visualization would look in monochrome, the absence of color is very important. And the key issue here is that the color should have high contrast. That is, there should be clear distinctions between shades of light and dark shades so that when they're printed in grayscale, they can be easily distinguished. Some tools to help you appreciate what colorblind or monochromatic vision might look like. On the web, there's a tool called Colourblindness, where you can upload an image and it will show you what different kinds of colorblind people might perceive. In Microsoft Windows, there's actually a color filter where you can change your screen to see what colorblind people would see. And there's probably similar tools for Mac OS. Then some smartphone apps that I find personally useful. Chromatic Vision Simulator lets you use your camera over any image or visualization or view, and it shows you what colorblind people would see. And that's what I use for this particular screenshot to distinguish what different kinds of colorblindness would perceive from the same image that people with normal vision would see. And for monochrome vision, that's to see what your visualization would look like if printed, you can turn on grayscale mode on your smartphone, and there's also ways to do that so you can turn on grayscale mode, and with that you can use the camera of your smartphone to then see what a visualization would look like if it were printed. Now, there's also the consideration for completely blind people. And how can we make visualizations more accessible to them? Would think that that's a lost cause, but not at all, because there are a lot of tools that can try to interpret visualizations, but this requires essentially including text that carefully explains the visualization embedded into our visualization so that screen readers can communicate their meaning to blind people. And here's another link that talks about key issues for data visualization accessibility, including principles for completely blind people. So hopefully this video has sensitized you to these important issues in data visualization so that you can carefully give a lot more thought in your choice of color so that it can effectively reach the largest audience to which you want to communicate your information.